is to go over sine, cosine, tangents, and to understand sine, cosine, and tangents. So let's look at this unit circle, and we have some one triangle here and other segments, which is vertical segments, which is AT. BS is also vertical, which is perpendicular to x-axis. And we have B here, and the arc length AB is exactly the same as this unit. So I can move the point B by doing this, and this number 0.83 units is the distance from A traveled to around the circle, or partial circle, which we call arc, to B. So that's the arc length. By definition, that is the radian. So let's take a look at this. And we got some lengths here, OS, which is from here to S, which is the intersection of intersecting points of perpendicular line going through B to x-axis. That distance from OS, or the length OS, is 0.675 units. And from that point, the distance to B is the 0.738 units, which is this one. And also notice that the segment AT, which is this one, the length is 1.09 units. So let's find out what the sine of x is. So this sine of x, that x is the radian, so I'm going to replace with this radian, which is 0.83 right now. So let's calculate sine of x. Sine of x is 0.783. Cosine of 0.83 is 0.675. Tangent of that radian is 1.09. Since this is the geometry software, let's move this B around to see if you can find the invariance, which is something that doesn't change. So when I move B prime to the right, then you realize that B is going towards pi halves, which is 90 degrees. As BS gets longer, AT gets longer, and OS gets shorter. You can see it from the length. But at the same time, I want you to realize that sine, cosine, tangent changes as well. Sine of x, or sine of the radian now, is 0.874, which is exactly the same as the length of SB. And cosine of x, which is cosine of radian, is 0.486, which is exactly the same as OS. And tangent of the radian, which is 1.06, at this point is 1.8, which is exactly the same as length of segment AT. So this shows that those lengths of the segments are exactly the same as sine